lecture 6.6, interest. We're going to talk about two types of interest, simple interest and then compound interest. So first, what is interest? Well, interest is the fee that either you pay or somebody pays you for the use of money. If you allow somebody the use of your money, they will in turn pay you a fee for the use of that money. If you use somebody else's money, then they want you to pay a fee for using their money. That's interest. So, if you invest in a bank, let's say, the bank will use that money while they have it, and then in turn, they'll pay you interest for the use. Plus, you get to take out all your money later on. When you borrow money, either in a loan or on credit cards, something like that, then for the use of that money, you're going to have to pay not only what you borrowed, but also an additional fee, which is called interest. Basically, there are three words we really need to know for this area. One is the amount of money that we invest or that we borrow is called the principal. The percent at which the interest is paid is called the interest rate or just rate. And then the amount of money that's paid for the use of that money is called interest. Now, to calculate simple interest, it's going to be our principal times our rate, our interest rate, and this is in decimal format, is going to equal our interest. For example, if my principal is $100 and my interest rate is 10%, the interest I have to either pay or I get is $10. So let's try an example. In 1999, the average interest rate for a 6-month CD, which means certificate of deposit, was 6%, meaning I'm going to give the bank some money and they're going to pay me 6% interest on the money that I let them use. A man invests $2,000 in such an account. How much money was in his account after a year? Now, here's something that we do need to know. Even though we're putting in the 6-month CD and it's locked down for 6 months, the interest rate is based on an annual interest rate. It's based on 1 year. So as long as we leave that money in there for a full year, we'll get the full 6%. So he does indeed leave his money in the account for a year. So we're going to use our principal times rate equals interest. In this case, our principal is $2,000. Our rate is 6% in decimal format, that's 0.06. So after 1 year, he gets $120, plus he gets his $2,000 back for a total of $2,120, just for letting his money sit in the bank for a year. Now let's think about a farmer borrowing money at $8,000 from his local bank, and it's at 5%. Again, that's 5% annual interest. How much does he pay back at the end of the year to pay back the total loan? So remember, he has to pay back the original $8,000, and he has to pay back the interest the fee interest that he has to pay back to the bank as well. So let's calculate what the interest will be. So the interest is the $8,000 times 5%, or $400. The total amount he has to pay back to the bank is the interest plus the principal. Therefore, it's $400 plus $8,000 for a total of $8,400. Now in the above examples, in the previous examples, we only dealt with 1 year. So we didn't have to take in consideration over time, but we can calculate simple interest over time. Time is usually considered 1 year at 360 days. Yes, I know a year is not 360 days, but that's how it's calculated. And we think about this in terms of, okay, well, maybe you took 60 days to pay off a loan. Well, then that's not a full year, and you wouldn't have to, pay a huge amount of interest, but just for the time that you had the loan taken out. So let's consider our IPRT, which is interest equals principal times interest rate, time in years. So we're going to use this 1 over 360 days, and depending on what the length of the loan is, if it's 20 days, 60 days, we're going to put that over 360 days. So let's try an example. So let's say a student takes out an emergency loan for tuition, books, and supplies. The loan is for $600 at an interest rate of 4%. How much interest does the student pay if the loan is paid back in 60 days? Now, the rate is an annual interest rate, but we're going to pay it back in 60 days. So, I equals PRT. So the principal is $600, the rate is 0.4, and our time is 60 days over 360 days. And days cancel out, so either you can add them on there and cancel them out, or just leave them off. But 60 over 360 reduces down to 1/6. So I have 600 times 0.04 times 1/6. But the 6 and the 1/6 and the 600, we can reduce that. And we're left with 100 times 0.4, or $4. So at the end, the student has to pay $604 for the use of that money. So in this example, a woman deposits $900 in an account that pays 2% annually. If she withdraws all the money in the account after 90 days, how much will she withdraw? So again, we need to figure out what the interest is, and in this case, it's 90 days. So the principal is $900 at 2% for 90 days. We multiply that all out, 900 times 0.2 times 1/4. She will get 4.5 or $4.50 worth of interest. But how much would she totally withdraw if she removes all the money? That will be 900 plus the 450 for 904.50. Alright, so we're going to change gears a little bit, and we're going to start talking about compound interest. And what compound interest means is at the end of the year you get all your interest, and then if you leave it in the bank, the next year's interest is going to be based on your principal and the interest that you accrued the previous year. So let's work through this. A physical therapist puts $3,000 in a savings account that pays 3.5%, and it is compounded annually. How much will be in her account at the end of 2 years? So we have to figure out what is the interest in the first year. Now, the 360 over 360 is just a 1, so we could leave it off. But it's 3,000 times 0.35. And she receives $105 for the first year of interest. So at the end of the first year, she has $31.05 in the account now. This is the new amount that's sitting in the account. Now, the second year, the interest is going to be based on the $31.05, not the original $3,000. So our interest is $31.05 times the interest rate, the 0.035, times our year, which is just 1. She receives $108.675. Now, of course, you're not going to get the 0.675 for the cents, so I'm just going to round up. So her new amount is going to be the $31.05 plus the interest she received in the second year, $108.68. So it's going to be approximately $32.13.68. Much different than if it was simple interest and we would have just left it in there for a full year. It would have been $105. But if you would have just done a simple interest again, that's another $105. So the difference is about $3.68 that she has earned because it compounds. Now, compounding doesn't have to happen just annually. It might happen quarterly, which means 4 times a year. So if we invest $10,000 in a savings account that pays 6% compounded quarterly, how much is in the account after a year? What this means is that we have to calculate the interest 4 times. So I'm going to run through this. Our first quarter, we're still going to use our 90 days because it's compounded quarterly, and we're going to figure out that our interest for the first quarter is $150. Now that $150 goes back into the account, and we have $10,150, which is earning interest. At the end of the second quarter, our interest we earned is $152.25. That goes back into the account. At the end of the second quarter, at the beginning of the third quarter, we have $10,302.25 in the account. That earns interest, $154.53 interest goes back in the account. Kind of never leaves the account, it just stays there. At the start of the fourth quarter, we have $10,456.78. Again, we calculate what is the interest for that quarter for a total of $156.85. At the end of the year, they started with $10,000 and they will have earned $613.63 worth of interest for a total amount of $10,613.63. Now that was a lot of work, and this was only for 1 year quarterly. What if they left this $10,000 in there for, say, 20 years? Then I don't want to have to calculate this 80 times to figure out what it's going to be at the end of that period to see how much money is left that is in the bank. So we have a special formula to calculate compound interest. So we're going to summarize what we did in the work above. P for principal of dollars. A is the amount in the account after so many years, which will be a T, compounded in times per year. So if it's semi-annually, it's twice a year. If it's quarterly, it's 4 times a year. If it's bi-annually, it's once every other year. Let's see the formula. Now, it might look a little scary at first, but we're just really plugging in numbers to figure out what the amount in the account is at the end of the year. So, A is for amount, P is for principal, R is for our interest rate in decimal format, N is for the number of times per year that it's going to be compounded, N again is the same N, and T is the number of years. So, using the numbers in our previous example, P is going to be 10,000. R is going to be 0.6. The number of times is quarterly, so it's 4. And our year is 1 year. So I'm going to plug all of that into the equation, the formula. So I have $10,000 times 1 plus 0.06 over 4, all to the 4th power. Now 0.6 over 4 is just 0.15. Add 1 to it, so you have 1.015, all raised to the 4th power. You're just going to use your calculator to do this. Multiply that by 10,000 and you get 10,613.63551 or thereabouts, and we're going to round it to change. Therefore, it's $10,613.64. This method, a lot easier than having to calculate it 4 times. This, we plug it in. We only have to calculate it once. And this is good for 40 years, 20 years, anything like that. It's perfect. So until next time, be seeing you.